All right, guys. So what are we going to be doing here? Well, we're going to be continuing the lecture from last time where we were evaluating limits analytically. And specifically, this lecture goes with homework 5, which is limits analytically for functions with removable discontinuities. So analytic limits, and I'm just going to say removable discontinuities. Now, something to keep in mind here is that discontinuities. Something to keep in mind here is that removable discontinuities is really a topic that comes in a section on continuity, and this isn't a lecture on continuity. So this is describing the type of functions, but really we're only talking about limits here. Okay, so last time we did the square root type. So if you're looking for how to do square root limits, what am I doing? Last time we did square root type limits. Square root type limits. This time we're going to do the fraction and the polynomial type. And if you remember, together the square root type, the fraction, and the polynomial type were the three types that I said you should know how to do. So yeah, let's go ahead and look at them. So the polynomial type is the easiest. So it's even easier than the square roots, which were pretty hard. So polynomial types. So polynomial type. And we talked about like what it was last time. So it's going to be a limit where basically you're going to have a divide by zero somewhere, and you're also going to have some kind of it's going to be 0 over 0 basically. So like if I go x minus 1 squared, so if you plug a 3 in there, what are you going to get? 3 minus 1 is 2, 2 squared is 4. So like that. Something like this, okay? And so the characteristics here that you need to be aware of are if you take the 3 and you plug it in for the x's, you should be getting 0 over 0. No surprise, that's what happens on these hard ones to evaluate. So you put a 3 in, you get 3 minus 1 squared minus 4 over 3 minus 3, which is, when you work it out, 0 over 0, right? And last time we talked about 0 over 0 was something that told us that we needed to spend more time evaluating the limit, figure out how to do it right. So 0 over 0, specifically, it's called an indeterminate form, and what it means is the limit could be anything, right? So we're not done. When you see 0 over 0, the limit needs more work. You can't even say whether or not the limit exists just from 0 over 0. Okay, so that's a polynomial type. Now, just before we get started on it, really, I want to mention the discontinuity part here. Discontinuity. So the idea is that this function is not continuous, right? So technically, not technically, it is. If you write out this function, so just without the limit, is not continuous at x equals 3. Why not? Well, are you allowed to plug in 3? No, you're not, right? So it's not continuous. The function value doesn't even exist at 3. You can't even plug in 3. Right? So it's not continuous, And so that's the discontinuity part of removable discontinuities. Now, what's the removable part of removable discontinuity? The removable part of removable discontinuity is, well, basically we're going to fix this problem, right? So when we fix the problem, that's removing the discontinuity. We're going to have a more in-depth discussion of this when we talk about continuity, but for today, it's discontinuous because you can't work it out right now. It's removable because we're going to take care of the problem, and that's all you need to know for the moment. All right, polynomial type. There it is. Now, what do we do? Now, the method is actually very easy, much easier than the root type method. All you do is you multiply anything out that you can on the top and the bottom. Then you factor, if you can, which you should be able to. And then you're going to, after you factor, then you're going to be able to cancel terms. And then you should just be able to plug in the x equals a, whatever the limit is, right, to evaluate the limit. So that's pretty much the same method that we used for the root type. I would say that the difference is that you do these when you start out by multiplying out the top and the bottom. There's no conjugates or anything to worry about. Okay, so let's see what one looks like here. So x minus 1 squared, let's do this one. Example, limit x to, 3? X minus 1 squared minus 4 over x minus 3. Right? So to get started, you always at least try to plug in the limit just to see what happens. And we already did this, but still. We get 0 over 0, right? So you try this first, which I didn't write in my steps, but you always try that. Try to plug in x equals 3. We got 0 over 0, which told us that we have to do more work. Okay, the next thing we need to do is actually get started with these steps here for the method. So we need to multiply out the top. And the bottom. But there's nothing really to do on the bottom, so we're just going to multiply out the top. All right, so limit x goes to 3. Remember what I said last time about these? You have to write the limit on every line of work. Okay. All right, so let's multiply it out. So we have x minus 1 squared. You're going to work that out, just multiply it. So x minus 1 is going to be x squared minus 2x plus 1. Then we got minus 4. On the bottom, there's nothing to multiply out. So you're just going to write x minus 3. There you go. So that's it. Now, I say factor if you can for the next step. Yeah, we're going to do that. But before we do that, maybe we should just actually simplify a little bit here. Right? Because this has got like a minus 4 and a plus 1. You can combine those and get x squared minus 2x, minus 3 over x minus 3, like that. And now we can move on to our next step, which is going to be factor. All right, so you have to remember how to factor polynomials. Some are easy, some are hard. If you're stuck, go ahead and use a computer. That's not going to be a problem. But, the way I do this is if you have, if the leading coefficient is a 1, then what you're going to do is you're going to take this number, not like that, y, you're going to take this number and put it up here. And you are going to take which number? This number, and you're going to put it down here. They should have a minus, huh? All right. And then what you're going to do is you're going to try to find numbers that multiply to this one, multiply to, and add up to this one. So you're looking for numbers that multiply to -3 and they add up to -2. So you just think about it for a while, and then you come up with -3 and +1. Right? If you multiply those, you get -3. If you add them up, you get -2. And together, that tells you that the top is going to factor into x minus 3, x plus 1. And in the denominator, nothing to do. So we just rewrite it. Okay? So we factored. The next step is we should cancel any like terms. That's going to be really easy to do, right? You should be able to see right away that there's an x minus 3 on the top. Why do I keep doing that on this one here? I want highlighter. So you have an x minus 3 on top. You have an x minus 3 on the bottom. Of course, that's going to let you just cancel those. When you do that, you're going to get the limit as x goes to 3 of, well, what do we have left? The denominator canceled, right? So it's just x plus 1 over 1 if you even want to write the denominator. And then your last step, after you cancel, should just be plugging in the x equals 3. So you're going to get, what are we going to get? You plug in your x equals 3, you're going to get 3 plus 1 over 1, which is 4. And that's your answer. Okay, and that's the polynomial type. Not too bad. Okay, now something I do want to mention before we go on here is that you can have a computer do as much of this or as little of this as you want. So like what do we have? X minus 1 squared minus 4. Okay, so like if I open up computer here, if I go to wolframalpha.com, if I type this in, you know, what was it? X minus 2 squared minus, what was it? 4, I guess. And then on the bottom, it was x minus 3, which also needs to be in parentheses. Come on. All right. So it'll give you a picture of the function. That's fine. If you scroll down, wait, did I type that in wrong? Hold on. This was supposed to be a 1, wasn't it? Where's notability? Oh, x minus 1 squared plus minus 4. All right, try again. Okay, there we go. So this is what it looks like. And if you scroll down, there's different terms. And, you know, you can look at it. Right here at the beginning, where it says input and output, or input and result, the result is after it canceled everything, right? X plus 1 is what we got. You can even ask Wolfram Alpha to do the limit. Just say limit as, I'll say limit of this thing as x goes to 3. Should just tell us 4. I think that's what we got. There you go. It doesn't provide any work or anything. It'll just evaluate the limit and give you the answer. Okay, if you want it to do work for you, you can go to Symbolab. Now, Symbolab is really hard to use on a laptop or iPad. Sorry, on a laptop it's easy. This is a little bit harder to do, but if I try here, we got a limit. Really, x to 3. Okay, and then this is where it's hard to type in. I need a fraction. How do I get a fraction like that? On top, we have where parentheses x minus 1 outside of the parentheses here. Did not do it. Come on. The world has exploded. Okay. I don't know if I can type this in here. Maybe I'll do a simpler one. So the reason this is so hard is because when you hit a key here, then what's happening is it doesn't show up. It doesn't show up until you hit the next key. And that makes it really difficult to do anything at all. Okay. Getting somewhere. How frustrated are you on a scale of 1 to 10 with how slow I'm typing this in? 10? Thought so. I think I did it. Let's try. Go. Okay. Now the limit is 4. Now the reason I wanted to go through this trouble, even though it's hard on an iPad, is because it has the steps here. So like it says, simplify this, and you end up with the limit as x goes to 3 of x plus 1, right? Right here in the middle. But it also has show steps. Now, looks like they locked them here, but on a lot of problems on Symbolab, you can get it to show you the steps. I'm not paying $1.99 to show you it, but if you wanted it to, you could make them show you how to do this limit. So that's the advantage of Symbolab versus Wolfram Alpha. All right, so back to our notes here. Okay, analytic limits. Okay, so back here. Sorry for how long that took. Let's look at the fraction type, and then after we have the fraction type, then we're going to do kind of just several advanced examples. All right, so fraction type. Fraction type. So remember the fraction type was exactly what it sounded like. It's still 0 over 0. These are all work out to 0 over 0. But it involved fractions, right? That makes it a fraction type. So pretty straightforward. Now, really, there's a couple of different ways to do this. The way I like to do it is not the way that your homework system will tell you how to do it. So I think first I'm going to do it the way that I like to do it, and then I'll do it the way that the computer likes to do it. As I said that, I realized that I was lying to you. I'm just going to do it the way that the computer does it. All right, so let's look at this. So basically what you're going to do is in the numerator and possibly in the denominator, sometimes it's 1, sometimes it's both, you've got fractions, okay? What you want to do is just add those fractions together, okay? So the top and or bottom have fractions. add those fractions. Okay? Now, after you add those fractions, you're going to have a fraction over a fraction or something like that, okay? After you do that, you're going to, if you now have a fraction over a fraction, that's called an improper fraction. I'll say a fraction in your fraction. Rewrite as a proper fraction, or I'm just going to say a regular fraction, as a single fraction. How do you do that? Well, like this. So like if you have a over b over c, that's just a over bc. If you've got a over b over c over d, when you have a fraction over a fraction, you take the one in the denominator and you rewrite it so it's multiplying by the reciprocal. So you use the reciprocal and rewrite it as a over b times d over c. So actually the reciprocal is here, right? So that's how you make it one fraction. Now after you do that, now you're kind of back to where you started on the other one, where you're going to cancel terms. Technically you might have to factor if necessary. So if you do, you do. And then after you cancel your terms, then you should just be able to plug in the number for the limit again, which we call evaluating the limit. All right. So again, the key there really is what we say here at the beginning, where you just need to add any of the fractions that you can add. So on the one that we have, it's not going to be that bad because I asked an easy one here. Let's try it. Example. We had limit as x goes to 4. What was it? 1 over x minus 1 over 4? Over x minus 4. All right. Now, as always, even if I forget to write it, your first step is really kind of try to plug in the 4 just to make sure that you have to do this. So if you do that here, you get 0 over 0 again. Okay? So just like all of these, you get 0 over 0. If you don't get 0 over 0, like if you plugged in x equals 4 and you just got a number, then you're done with the problem, and that number is your answer, okay? So there we go. What do we want to do? Add the fractions, right? That's our first step. Add fractions. So specifically, right, what we're talking about is we've got this 1 over x minus 1 over 4, right? So you have, let me rewrite it. Limit x to 4, 1 over x, 1 over 4, x over 4. So here's the fractions that we're adding. We need to add them. You need a common denominator. So the common denominator looks like it's going to be 4x, right? You can get a common denominator just by multiplying whatever is in all the denominators together. It's not necessarily the best one, but you can get one that way. So in this case, that's the common denominator. So, oops. Common denominator is 4x. What you want to do is get that common denominator. So we have 1 over x. We've got 1 over 4. So in order to get the common denominator on both of these, The second one is missing the x, so we multiply by x over x. The first denominator is missing the 4, so we multiply by 4 over 4. Right? Basic rules of fractions here. So multiply that out, you get 4 over 4x minus x over 4x over x minus 4. All right, almost done. Do this step here, we've got space. What you need to do is actually add those fractions, right? That's what the goal of this step was. So if you add these fractions, we're going to get one fraction over 4x, and then the numerator is going to be 4 minus x. There you go. Okay, so that's it. We added the fractions. So what's next? You now have a fraction in your fraction. Rewrite it as a single fraction. So, right, we got a fraction in our fraction. So, how are we going to rewrite that? Well, a couple ways to do it. Rewrite as a single fraction. How? Well, you can treat it this way. This could be your top fraction, and then your bottom fraction just add over 1, like that. And now you can add them, where are we? You can add them exactly using this method, right? If you're dividing a fraction by a fraction, you multiply by the reciprocal. So we are going to get a limit as x goes to 4 of the top fraction, 4 minus x over 4x, times the reciprocal of the bottom one, which is now 1 over x minus 4. I had to add the 1, but there you go. Okay. Now I say to rewrite it as one fraction, and so I should not write it as 2. I should have it as 1. So if I do that, the denominator is 4x, parentheses, x minus 4, just multiplying across. And then on the top, you've got the 4 minus x times 1. So that's 4 minus x, 1. And you don't need to write the 1, but I wrote it there because it's not always going to be 1. Okay, so we rewrote it as a single fraction. Now my next step is cancel terms, factor if necessary. So this one has a very small amount of factoring to do, but it does have something that we need to do. Cancel terms. So let me just rewrite it. We have a limit as x goes to 4 of 4 minus x over 4x x minus 4. Okay, so what you should notice about this is that this term, 4 minus x, and this term, x minus 4, are almost the same, right? What's different about them is that they're in a different order, okay? And so what you have to do is just keep this in mind. If you had minus x minus 4, what would it be? If you had a minus here, you'd have minus x and then minus minus 4. Minus x minus minus 4, which is 4 minus x. Okay? Now, that's messy right there. I'm going to erase it actually because it's messy. But here's what I'm saying. 4 minus x equals minus x minus 4. So you can take this, reverse the order, and then add a minus sign, and they're the same thing. Okay? So if you do that here, we can make the top and the bottom match. You just have to take out a minus, and then instead of 4 minus x, it's x minus 4. Now the top and the bottom match exactly, and you can cancel the x minus 4 with the x minus 4, leaving you with limit x to, should be 4. Well, what happened? In the numerator, the x minus 4 canceled. There's still a negative up there, -1. And in the denominator, we just have 4x. Almost done. Last step, we should be able to evaluate just by plugging in 4. So what's that look like? Limit x to 4 of -1 over 4x, which is -1 over 4, which is -1 over 16. And that is your answer. All right, and so that's the basic steps for any of these, what are they called? Any of these types of fraction limits. Okay, now what I'm going to do now is just spend probably another 10 or 15 minutes just doing a couple problems from the homework just to make sure that we're comfortable with it. Okay, so here's one that I see on the homework now. So these are just examples. So this is example from homework 5. We've got a limit as x goes to 0 of x squared over x minus 5 plus 25 over x plus 5. Okay, so first of all, what type is this, right? You should recognize it as a fraction type, okay? But on every one of these limits, your first step needs to be try to plug in the x value, okay? Try to plug in the x value, see what you get, because you may not have to do all this algebra work, okay? So you try to plug that in. So you plug in x equals 0. What are we going to get? 0 squared on top, 0 minus 5 plus 25 over 0 plus 5. So I get 0 squared over minus 5 plus 25 over 5 is 5, which is 0 over 0. Okay, so this is 0 over 0. That means I do have to go through the steps. Okay? All right, so let's do it. Let's do the steps here. So our first steps are going to be, number 1, we need to add any fractions. Glad we started with this one too, because looking at it, I only have one fraction, right? But I'm going to actually have to add all this stuff together. When we say add fractions, we're going to add all of this. Okay, so we add all of that. Now, while we're writing that down, then what is the common denominator going to be down there? Well, there's only one denominator, right? So the common denominator is just going to be x plus 5. So plus 5. All right, so common denominator is x plus 5. So what we're going to do is limit x to 0. There's nothing to do in the numerator, right? So I'm just going to write it again. In the denominator, everything needs to end up x plus 5. So I've got an x, some space, a 5, some space, 25 over x plus 5. Right? So this is what we have so far. We need to get the common denominator everywhere. That means this one needs to be multiplied by x plus 5 over x plus 5. And the 5 needs to be multiplied by x plus 5 over x plus 5. So both of those terms need to get the common denominator. So we have a limit as x goes to 0 of x squared. This first fraction is x plus 5 over x plus 5 minus 5x plus 5 over x plus 5 plus 25 over x plus 5. right? The last one we didn't have to do anything to. So now they all have a common denominator, x plus 5, x plus 5, x plus 5. So we can add those fractions. So add the fractions. We get limit x to 0, long thing, one fraction down here, x plus 5 minus 5x plus 5 plus 25, all of that over x plus 5. Right. So now we've added the fractions. We can do a little bit more simplifying here though. So let's do that before we move on. So this is not really a step. I'm just going to simplify a little. Which, I mean, just multiply this stuff out. So I've got x plus 5. What's that? X squared plus 5x. Then you've got this part. Make sure you pay attention to that minus sign, right? So I've got minus 5x. And then with this and this, I'm going to have minus 5 times plus 5 is going to be minus 25. And then I've got the last 25, which is plus 25 here from this. Okay, so I multiplied it all out. I think I should just be able to add these together. Don't think I need that much room actually. All right, so add it all up. So what's going to happen here? Well, first of all, I can just notice that I have plus 5x and minus 5x, and also minus 25 and plus 25. So that's a lot of stuff that just canceled right there, right? I'm not really supposed to be at that step yet, but here's what I've got. Everything canceled except for the x squared. So here's where I am now. Okay. What are we going to do with that? Well, we're going to move on to the next step, which is going to be rewrite it as a single fraction. So that means you're treating this as one fraction and this as another fraction. So I need the reciprocal of the bottom one, right? So I have x squared times the reciprocal of the bottom one, which is x plus 5 over x squared. Multiply those together. I've got x squared, x plus 5 over x squared. And our next step is going to be cancel terms, which should be easy to see what to do now. There they are. So I have a limit as x goes to 0 of just x plus 5 plus. Evaluate. How's that going to work? Should just be, well, actually, no limit, because we're going to evaluate by plugging in x equals 0. So that's a 0. So plug in the 0, and you're going to get 0 plus 5, which is 5. So that is your answer. I don't know why I'm typing it into the computer here. So that's kind of a lot of work, but there you go. Book kind of solved it in a slightly different way. There we go. That's exactly the same. Trying to find one that looks different. That's exactly the same. Okay, yeah, let's do another square root one. We haven't done one in this lecture. Example. Limit x to 4 plus 9 minus square root 13 over x minus 4. All right, so let's see if we remember this from the previous lecture. Okay, so on all of these, what do you try first? You try to just plug in, the 4, right, for all of the x's. So if you try that, you're going to get, what are we going to get? Square root, you put in the 4 there, it's going to be 13 minus square root 13 over 4 minus 4, which is 0 over 0. You know, like all of these, right? Because they're trying to show us how to deal with this issue. All right, so how are we going to deal with this issue? I'm just recopying it. Okay, so what was the method here? What we're supposed to do is we're supposed to multiply by, what was it called? It was the conjugate, right? Remember that? The conjugate. So the conjugate here is wherever your square root is, which in this case is the numerator, the conjugate is going to be that thing with the sign reversed. Now be careful, because I said reverse the sign. That's this sign, okay? Not the plus sign in the x plus 9, right? So the conjugate of this term right here is square root x plus 9 plus square root 13. Okay, so only that one sign that I highlighted is what you change. You don't just change every single sign. You just change the one that turns it from a minus b to a plus b or a plus b to a minus b. Not every sign in the whole problem. All right, you have to multiply by the same thing top and bottom, so we did. Now, how are we going to deal with that? So, what's going to happen is in the numerator, I'm just going to copy it again out like that. And in the denominator, I'm going to copy that. I'm not really multiplying anything, I'm just copying stuff. Okay, so I just rewrote it as one fraction. Now, the a minus b, a plus b, that's in the numerator, right? Like this is your a, this is your a minus b, and I did it again, why? And then this is your a plus b, okay? So those are your conjugates. That's what's going to turn into, your, well, you can't even read that. That's what's going to turn into your a squared minus b squared in the numerator. In the denominator here, you don't want to do anything. So that's reversed from the previous example that we did in the last lecture, where it was the denominator, I think, that needed to be multiplied out, not the numerator. Okay, but it's where the conjugates are. That's the ones that you care about. Okay, so remember, if this is your a and this is your b, then my a squared minus b squared is a squared minus b squared. Okay, that's my a squared and my b squared. What do you do in the denominator? Or wherever you don't have the conjugates? Hopefully you remember. What you do? Nothing. Don't multiply it out. Don't multiply out the part that does not have the conjugates. Because later on, we're going to be canceling terms, and if you multiply it out, you ruin that, okay? You actually make the problem worse if you try to multiply it out. Don't want to make it worse. It's already bad enough. Okay, so what do we actually get here when we do this? So when you square a square root, it's just going to cancel, right? So like that's going to cancel with the square root, that's going to cancel with the square root. We're going to end up with just x plus 9 I'm going to put that in parentheses, minus 13. I'm going to put that in parentheses. What do we do in the denominator? Nothing. Just copy it again. Just keep copying it. We're only worrying about those conjugates. Okay? Now, okay, there we go. We got here. Now, why the parentheses? The reason I have parentheses here, here, is because without the parentheses, the minus sign that's in the middle, this one, that minus sign might mess your problem up if you don't have parentheses. Now, in this case, it doesn't matter, right? Because it's minus 13. But what if the terms were the other way around? What if it was minus x plus 9? If the x plus 9 was where the 13 was, then whether or not you wrote parentheses matters. So do write the parentheses and work through them properly. All right, so what do we get in the numerator? I got a plus 9 minus 13. I think that's x minus 4. All right. So that's it. We multiplied out our conjugates and stuff. So then what are we going to do? We are going to, I don't know what number, 2? I feel like further. Cancel terms. My numbering is probably different than before. All right, cancel terms. You should be able to see where to do it, right there and there. So I'm going to get 1 on top because I canceled it. And then on the bottom, square root x plus 9 plus square root 13. All right, there you go. Now, as soon as you do your canceling, like we just did, then you should be able just to plug in your limit, evaluate your limit. Evaluate. Okay, try to do it here at the bottom of the page. Limit x to 4, 1 over x, I don't know why I'm recopying it, square root 13 equals, plug in the 4. 1 over square root 4 plus 9 plus square root 13, which is 1 over square root 13 plus square root 13. Out of room, I'm going to go up here, equals 1 over 2 square root 13. Okay, now that's actually a perfectly fine answer, but it doesn't match the one that you have a choice on the homework, and that's because normally when you have square roots in your denominator, they want you to do what they call rationalize the denominator. So to match the answer in the book, or rather the online homework, on the homework 5, what you need to do, you need to rationalize the denominator. That's not part of the limit evaluation. We're really done with the limit, but they just don't want to see the answer the way that I have it. So I've got 1 over 2 square root 13. So to rationalize this, you just multiply by square root 13 over square root 13. You should remember that from other classes, not from this class. And then on the top, you end up with square root 13. On the bottom, you have square root 13 times square root 13, right? I'll write it out this one time for you, but there you go, which is square root 13 over 2 times square root of 13 squared, which is 13. Overall, it's square root 13 over 26. And that is the answer that they actually have on the homework. And it's multiple choice. So if you only had this answer, then you wouldn't even find it on the list. Okay, you'd have to, well, probably what you would do is punch it into a calculator or something. That's how you would check if it was the same as yours. There you go. Remember, for all of these limits, Wolfram Alpha can do the limit for you. I'm not saying that you should use Wolfram Alpha for every limit, but you can definitely use it to check your work. Okay, and maybe Symbolab will show you the work, but you know, maybe not. Okay, so that is that. I think we're done.